In this video, we're going to be looking at how we can graph logarithmic functions via their transformations. So that is really what we're looking at here, are logarithmic functions. And very specifically, these are ones with a b-value greater than 1, which is the majority of logarithms out there. And we're also going to be looking at ones where their transformations are only shifts. This process would work with other transformations as well, but specifically now we're going to be looking at ones that have transformations. So that would be a shift up or down, or a translation left or right. So as we're looking at that, you guys can see here, this is what our steps are going to be. So the very first thing we always want to do is we first want to identify what is our parent logarithm. That's going to help us find our original points. And when I say that, I mean like, what is the base? Is it a log base 2, a log base 3, a log base 4, a common log, a natural log? And then we're going to identify what transformations are there, apply those transformations to the coordinates, and then we can just go ahead and plot our new function. One of the reminders here is that if we have y equals a plus log of x plus b, our a value is going to be our vertical shift, and that's always going to be normal. So you would take your y values and just add that a value to it, versus the b, because it's inside with our x, that is our horizontal shift. And that's always going to be backwards or opposite. So if it's x plus b, you're actually going to do x minus b. So we're always going to see that opposite relationship here. So here what I'm going to do is I'm actually going to start once again by saying finding my parent function. So here my parent function is log base 2. So I need to start finding some coordinates. And they're going to be of this basic parent function. When we're finding coordinates for a logarithm, they almost look a little backwards. And that's because we know that a logarithm is saying what was the exponent. So the output represents the exponent, and the input, or the x value, represents that original, that kind of perfect power. So here, since it's base 2, I might do 2 and 1. And that is once again because log base 2 of 2 is saying what exponent turned 2 into 2? Well, that exponent was 1. I might do 4, and the exponent that turns 2 into 4 is 2. I might do 8. The exponent that turns 2 into 8 is 3. I like to do 16 as well. The exponent that turns 2 into 16 is 4. Now we also want some smaller values, and so we know this one should always exist, 1. The exponent that turns 2 into 1 is 0. And then we can take these and make them the reciprocal, their fraction form, and that's going to give us those negative exponents. So this is just the first step, is always finding the points of your parent function. Once you have found that, then we can look at the transformation. We're going to create another table from these, and we're going to transform them. So here we have x plus 3. Because that's inside the parentheses, that's actually going to be the opposite. So that means we're going to do x minus 3. We're going to take these values and subtract 3 from them. So that's going to give me negative 2.5, negative 2, negative 1, 1, 5, and 11. And once again, I just found these by taking my original x values and subtracting 3. So 1 minus 3 is negative 2. 2 minus 3 is negative 1. 4 minus 3 is positive 1. 8 minus 3 is 5. 16 minus 3 is most definitely not 11. Sorry, 16 minus 3 is 13. So now that I have those, I can look at my y values. This a value out here tells me what to do to my y's. And because it's outside, it does it exactly the same. It's normal. So I'm going to take my y values and I'm going to subtract 2 from them. So now I'm going to take these, and I'm just going to subtract 2. So that gives me negative 3, negative 2, negative 1, 0, 1, and 2. Now that I have these, I can go ahead and plot them. Negative 2.5. So negative 1, negative 2.5, down to negative 3. 1, 2, 3. Negative 2, negative 2. Negative 1, negative 1, 1, 0, 5, 1, and 13, 1, 2, 3, 2. Now, this might be a little hard to see the shape of it perfectly, so the other thing that I like to do is to draw in those transformations. And that helps me see this a little bit more. This line here represents my vertical asymptote. So I know that as I get to this, I'm going to start going down in pretty much a straight line. And then I can go ahead and spread my logarithmic shape out. So there you have it. That is how we can go ahead and use transformations to help us graph a logarithmic function. So we start with the parent function, those original points. We identify our transformations. So inside the parentheses, that's always going to be opposite for our x values. Outside the parentheses, it's going to be normal for our y values. We go ahead and do those to our parent functions, and those gives us our new coordinates for our new functions that we can go ahead and plot and work with. I hope that helps.